AP Cram, Calculus AB. For your response, exam review. Question 53. Speed. Determine whether increasing or decreasing. All right, even if you don't really know what's going on, let's just get this over with anyway. A particle moves along a straight line for the closed interval t is either greater than or equivalent to 0 units of time, or t is less than or equivalent to 5 units of time. The velocity of the particle is given by v of t is equivalent to -2 plus t squared plus 3t all raised to the 6/5 power minus t to the third power. And the position of the particle is given by s of t. It is known that s of 0 is equivalent to 10. All right, so this is what we're going to answer. All right, is the speed of the particle increasing or decreasing at time t equals 4 units of time? And give a reason for your answer. This, a lot of people might think they know the answer straight away, but a lot of people forget to consider one additional factor, okay? So a lot of you know how to solve this. Just go ahead and I'll give you a moment to formulate your answer. All right, so here what we have to consider is both the velocity assessed at t equals 4, and the acceleration assessed at t equals 4. A lot of people just look at the acceleration and not the velocity, okay? So let's go ahead and do that. V of t, we know the formula. This is just it rewritten. And 1.2 is simply 6 divided by 5. So when you plug in v of 4 and you simplify it, you get negative 11.476 units of position over time, okay? Now, a of t is just the derivative of v of t. And in case you don't know how to take the derivative of v of t, let's just break it down quickly, verbally, term by term. So the derivative with respect to t of 2 is just going to be 0. We're going to leave this monster alone for a bit and jump here. We can apply the power rule to negative t to the third, letting n be our 3. So we bring n down, subtract 1 from n, and that's how we get negative 3t squared. Now for the middle term, we're going to have to apply the chain rule and the power rule. So what we do is we take the derivative, we let u be equivalent to t squared of times 3t. So we take d du and then we do d dt, okay? So the derivative of the outer function is just going to be n, which in this case is 6/5. So we bring down 6/5, which is the same thing as 1.2. And then we raise whatever is inside the parentheses to the n minus 1. So 6/5 minus 5/5, because in this case 1 is equivalent to 5/5, is going to leave us with 1/5 power, which is the same thing as taking the 5th root of the term inside the parentheses, which is t squared plus 3t. And then the chain rule says we have to multiply the derivative of the outer function by the derivative of the inner function. So again, for the inner function, we just apply the power rule, letting n be 2 here, so 2t raised to the n minus 1, which is 1. That's how we get 2t, plus the power rule here again. So t to the 1 is 1, so 1 times the constant 3 that's already present, so it's going to be 3. And the n minus 1 power is 0, so anything to the 0 power is 1. So t to the 0 is just going to be 1. 1 times 3 is 3. That's how we get our 3. All right, okay, that was a little detour. So now we analyze the acceleration at 4. Oh, yeah, you have to, in order to figure out the acceleration of the particle, if you're not already given the formula, you just take the derivative of the velocity. For those of you who are wondering why we're considering the acceleration, okay? All right, so when we analyze this equation, we get negative 22.296 units of distance or position over units of time squared. So one could easily say, oh, the acceleration is negative, it's decelerating, therefore the speed is increasing. But you have to realize that the velocity is also negative. So the speed is increasing at time t equals 4 because the velocity and acceleration have the same sign, okay? They're going in the same direction. Because they're going in the same direction, they might not be going in the positive direction. They could be going to the left. So this little arrow right here could represent the velocity, and this could represent the acceleration. It's like putting your car in reverse and then stepping on the gas. Like your velocity is increasing just fast.